sketch this. When you're done, move on. Great. So, look, you'll often see a picture like this where there'll just be an angle, you have no idea what the angle is, and then just some random point. And this is just to understand some basic concepts of how rotations work with the unit circle, or really just with trig in general. Keep the same things in mind that we already know. Right, what are those things? Well, we know the sine in general refers to the y value, and we know that theta is an angle. It's this angle here. And we know that a negative theta would mean we would have to go the opposite direction, right? So maybe it's helpful in general to sketch those angles. So let's see. If I take theta and add 2 pi, where am I going to end up on this circle? Well, it's actually not as crazy as you think, right? If I start at 0 and then I add 2 pi, I end up in the same place. So this question is really saying, what is just the sine of theta? Meaning, write the y value down. Y value is 0.687, and so that's what I write. And that's all there is to it. This question says, look, I'm going to take theta, which is here, and I'm going to subtract pi. Negative means, yeah, I go the other direction. So, in other words, it's just a straight line over. Let's look to a unit circle and see what happens. So I'm going to pick any of these numbers. Doesn't matter which one I pick, and see if there's a pattern. So I'm going to pick this one. Okay. So if I pick this value, which is, so like say pi over 3, the y value here would be the square root of 3 over 2. Let's take this line all the way down, because that would be like adding pi to it. And the y value here is a negative square root of 3 over 2. So what's happened? I went from being a positive to negative, and that's it. That's right. So look, if you're just moving it over, this number stays the same, right? It's still 0.687, right, except for the fact that it's negative now. Why is it negative? Well, because in quadrant 3, x and y are negative. We're talking about y value, so it's a negative 0.687. Here's the key. Use quadrants to determine the sign. In this case, I mean SIGN, right? Whether it's positive or negative, right? Use quadrants to determine the sign. Plus, plus, negative, plus, negative, negative, and plus, negative. So that'll help govern that. Okay, now let's go over to this one. This says, look, not positive, but negative theta, and then I'm going to add pi to it. So I'm going a negative theta, so I'm here. That's what this part says. And then I'm going to add pi to it. So let's again use the unit circle to come up with an idea. So like not, let's say, not pi over 6, but a negative pi over 6. The y value here is a negative 1/2. But it started at being positive 1/2, right? It went positive 1/2, negative 1/2. I go all the way across, it's positive 1/2. So if I do a negative theta plus, so here's theta, if I do a negative theta plus pi, that'd be over here, it ends up being the same value as if I had just done positive theta. In other words, look, this should reflect across. In other words, it's 0.687. Let me give you a couple more examples, and we'll be done with this for now, and we'll do some further development of this stuff in class. So cosine of 3 pi minus theta, and to really do this properly, it's kind of helpful to write, like, what is just cosine of theta, right? I mean, we know it's the x value, so let's write it down. We know that sine of theta is the y value, so let's just write it down. All right, that'll just be a helpful reference from here on out. So cosine of 3 pi minus theta. Here's the key. If theta is ever negative, then you should do it first. In other words, I've got to look at, I don't look at 3 pi and then take negative away. I start with, what does this say? It says a negative theta, so I'm here, right? That's what that says. It says I start here. And then I'm going to add 3 pi to it. Well, a pi, remember, is like a line. So I'm going to add one line. So right, I added one line, added a second line because it's 2 pi, and a third line because it's really 3 pi. So I ended up right here. It's the x value, so that's 0.324. Is the x value positive or negative in quadrant 2? That's right, it's negative. So I write negative. Let's keep going. Tangent is what over what? Right, it's y over x, so remember that. It's going to be a fraction, y over x. It's a negative theta, so here's a negative theta. And it's y over x, and y is 0.687. And is y positive or negative in quadrant 4? That's right, it's negative. So over x, that would be over 0.324. Is x positive or negative in quadrant 4? It's positive, and so that's my answer. Lastly, I'll do sine of theta plus 3 pi. So I'm starting here at theta. I'm going to add 3 pi, so 1 pi, 2 pi, 3 pi. I'm stuck down here. It's sine, so it's 0.687. Is it positive or negative? It's quadrant 3, so it's negative. And that's it. If this seems tricky, it's because, look, we're not used to adding and subtracting angles. We're not yet familiar with the fact that adding pi is like just going straight across, right? It's like just drawing a line straight across. Adding 2 pi is essentially, right, adding 2 pi was landing in the same spot as before. It's going all the way around the circle. So those are the kind of generalizations you'll want to make and understand to be able to move forward. Now let me start by saying you cannot just write down the numbers like before. What you need to do is pick any value. Look at your unit circle. Pick any theta and do what this says to do here. Do what this says to do here. And see if you can make a generalization. So see if you can bring a rule to class that explains what to do. If you don't see, that's fine, but push yourself and even make it more examples. Add, subtract pi over 2, add pi over 2, add or subtract 3 pi over 2. Because we want to make an example. What happens, and the question is, what happens when I have plus or minus pi over 2 or plus or minus 3 pi over 2? Something different happens. See if you can figure it out, bring it to class. If you can figure it out, I'll give you a high five or something. All right, see you there.